So thanks for joining me in this session and giving me the opportunity to present you our typed index. My name is Christoph Goller. This is the outline of my presentation. I start with a few words about me, about myself, and about the company I work for. A very brief introduction to what analyzers do and what the inverted file index is. We already had this morning. Then I'm going to talk about different types of terms and why we need them and why it's a good idea to have them in one field instead of having them in different fields. What's the standard approach? And in the end, I show what advantages this typed index has in the case of multilingual search, especially with mixed language documents. So about a few words about myself and about IntraFind. So I got this nice T-shirt as a Lucene committer. Actually, I worked on Lucene very early, from 2003 until 2007, about that time. And unfortunately, the company IntraFind took more and more of my time, and so I stopped really working and committing on Lucene. But I still follow most of the details on the changes in Lucene, and I'm still massively using Lucene. We are using it in all our projects as the base of the fundament of our company. So IntraFind is a specialist for information retrieval and enterprise search located in Germany, in Munich. The company was founded in the year 2000, and most of our customers are in German-speaking countries. So we have about 30 employees, and what we do is we offer consulting with text analytics, Lucene, Solr, Elasticsearch. We offer plugins for Lucene, Solr, and Elasticsearch. We have our own products, which are a combination of open source components and in-house developments. And in the field of information retrieval or enterprise search, we specialize on quality, that is improving the search quality with text analytics like linguistic analyzers, semantic search, named entity recognition, text classification, so technologies like this. And we also have switched our products to a search-oriented architecture in the meanwhile. So we have everything is services in our products, from the connectors to different source systems which contain documents, to converting services, text analytics services, and of course Solr or Elasticsearch as search behind that. So this is just an overview of important customers. So we are doing a lot of business in the car industry, Volkswagen, Audi, Bosch, but also in the publishing companies like Zeit Online or Wolters Kluwer, and also public organizations. So brief introduction to analyzers and the inverted file index. So an analyzer in the Lucene context, I think all of you know that, it's the component that produces a stream of tokens or a stream of terms from text. Text basically is a stream of characters. So the first step in an analyzer is always the tokenization, how to break this stream of characters into words, and then you may have one or several steps of normalization of these words, and you may have a stop word removal, stuff like that. That's the analysis. And the data structure, it's exactly the same slide we saw in the morning. So we have these 6 documents, and what is produced is the inverted file index. So we have a alphabetically sorted list of all the terms of these documents. This is the term dictionary, and for each of these terms we have the frequency, which is not so important for this talk, and we have a posting list. The posting list consists of, if we look at, for example, the word house, where do we have it? Here, is the word house. The posting list is, it occurs in document number 2 and number 3. House and house. And but actually, this is the posting list, but Lucene adds to this positions, which I have written with this syntax with parentheses. So this means house occurs in document number 2 at word position or token position number 5. 1, 2, 3, 4, 5. Yeah, and at position word position 2 in document 3. These positions are needed for phrase queries or for SpanQueries, for everything where it's important how close different parts of your query are to each other. What's the distance, the word distance between them? Let's look at different term normalizations or different types of terms. So why different term normalizations? The word normalization implies that the thing you put into it produces a normal form, which usually is one form. But actually, we have more than one normal form. The normal forms you're certainly used to are the forms that are produced by stemmers or by morphological analyzers. So if you look into Lucene contributions, you see a huge number of stemmers. These are, almost all of them are simple algorithmical stemmers. What they do is they chop off some very frequent suffixes of words. And since these frequent suffixes are language specific, this means stemmers usually are language specific. So you have, for I think about 30 different languages, you have specific stemmers or analyzers in the Lucene contributions. An alternative to stemmers are morphological analyzers, or which, for example, we have developed. So if you look at a comparison, what a lemmatizr does is it maps inflected forms of words to their base forms. So for example, here on the left side for English, for going, the lemmatizr knows this is a verb form, and the base form of this verb is go. So it produces the base form and the category, which category in this case is it's a verb. Yeah? And the same for irregular words like bought, the base form is buy, it's also a verb. Yeah? Bags, it's a plural of a noun which has the base form bag. So this is what a lemmatizr does. And lemmatizr for English might be quite straightforward, because English is a language where you don't have so many inflections, and most of the words are regular. But if you go to other languages, German, French, or Russian, which have much more inflections, it becomes much more difficult to have a high-quality lemmatizr, and this is mostly lexicon-based. So you can't really write rules or an algorithm. It's mostly lexicon-based. And for some languages, like for German or for Dutch, you have an additional complexity, because these languages allow to build compound nouns from smaller lemmas. So for example, in German, if you want to have the concept, if you want to use the concept of a children's book, which is a phrase in English, 2 words, children's book. In German, this is 1 word. It's Kinderbuch. Yeah? The same for insurance contract, which in German is 1 word. It's Versicherungsvertrag. So the German allows to build very big compounds from smaller semantical units. And if we compare algorithmical stemmers and morphological analyzers, lemmatizers, we see, for example, if we do a search on the Lucene user list, it's an older slide for my colleague, his name is Messer. It's also used to be a Lucene committer. If you do a search, you get hits with Bernhard Messer, but you also get hits like mess of it, messed up, because stemmers tend to do overstemming. So what they do is they just cut off some suffixes, and for example, if they cut off in English ing, they would produce K from king, or they could, for very different words like several or server, they might produce the same stem, even if these words don't have anything to do with each other semantically. So this is produced from a Zeit Online, where we have a Solr installation for the search, which uses our morphological analyzers. And you see here the difference if you do a search for buchen. This is the verb, in a German verb, which means to book a journey. Buchen means to book. And you get hits with überbuchen, like it's an irregular word, or buchen, gebucht. And if you do a search for something which looks quite similar, like Buch, which means book, you get totally different hits, like Buch here, or even within a compound, Bücherregale, irregular plural of book, or even within compounds. Here's a special example how word decomposition can be useful in search. So, for example, if you look at the word Bundesfamilienministerium, it's again such a big German compound, and actually it means Federal Ministry for Family Affairs. Most of the time, people really write or say Bundesfamilienministerium, but sometimes they can also say, use such a phrase, so they can say Bundesministerium für Familie, or Ministerium des Bundes für Familie, what actually would be this phrase, more or less. So in German, you have different possibilities to express the same concept or the same word, either as a big compound or as a phrase. And if you do search, you want, with your query Bundesfamilienministerium, you want to get all the hits, if it's written in the compound or if it's written as a phrase. So this is why it makes sense to have this word decomposition, in at least for German or for Dutch. But what I actually want to talk about is, why do we need more than one normalization? So we have seen stemmers and lemmatizers, and we have seen they are language specific. So this already means, if we don't know in advance or if not all documents from our content have the same language, we already have more than one normal form. But we still have to look at other things. For example, people not only use search in enterprise search, people not only use search as we used in Google, they really do some expert things. They use wildcard queries, they use fuzzy queries. And for these queries, they don't want to have to go, their wildcard query shouldn't go to stems or to lemmas. That's not what they expect. So wildcard and fuzzy queries should go to another form, to another normal form of the terms, maybe to the tokens as they come from the tokenizer without any normalization, but maybe with mapping everything to lowercase, and maybe with doing some very simple normalizations like Citroën, these dots from French to Citroën, because this is something I couldn't even type on my computer. So Solr has a similar concept for that. In Solr, you can define for a field or a field type, you can define an analyzer type multiterm, which actually defines on which normal forms your wildcard and fuzzy query will work, besides the analyzer you're using for the normal search and store and indexing process. And I think behind the hood, maybe someone knows better, behind the hood, they are using different fields, I think, if you specify a analyzer type multiterm. But you see, there's a need for another normal form of your content besides what your stemmer or lemmatizer produces. And there's still other cases. Lemmatizers and stemmers usually map everything to lowercase, because it shouldn't make a difference whether a word is at a sentence start or whether for some reason the whole text is in uppercase or so. But sometimes case is really important for search, especially we have a customer the company is named MAN. It's a very big company producing trucks and buses. And everything is written in uppercase. And so if a user types in the query, uses really uppercase letters, this certainly means something. He doesn't expect to get all documents with this written in lowercase, which is actually nearly a stop word. Yeah? So sometimes case matters. This means you cannot only rely on lowercase stuff and stemmers and lemmatizers. And think about if you add phonetic search, another normal form. And there are different algorithms for phonetic normalizations. That means there's not one phonetic normal form, but there are different algorithms which produce different normal forms. You might want to combine several. And yeah, if we look at them, because they become important for later slides, for examples, the word Muslim, which is a name, and the word Muslim, the Muslim society, they both get the same phonetic normal form with this double metaphone implementation. Interesting is, if you look at book and the plural books, they get different phonetic normal forms. Yeah? And this is just a name of a writer from Tunisia, which used to be a friend of mine. Yeah, this is the phonetic normal form. Since I'm not from an Arabic country, I might not know how to spell this name correctly. This is, I might need phonetic search if I search for this name. Another form of normalization or term type that might be important is if we do named entity recognition on your texts. And we're doing this quite frequently. So named entity recognition is you can identify people names, company names, locations, and stuff like that within your structured text. You can put it into separate fields for facets, for example, but you can also use it for search. You can, for example, then have a query which says, I'm looking for brown, the word brown, but not the color. It should be part of a person name. Totally different search, which a much more interesting search result, maybe. Yeah? So another type of term. So the question is, why do we need these different types of terms in one field? Because the standard approach, if you do it with Solr or Lucene, the standard approach with these forms, if you want to add phonetic search, make a copy field, add another field for which you use the phonetic analyzer. If you so normally you just add another field and use a different analyzer for this other normal form. So why could it be useful to have these different terms, these different types of terms still in one field? I think the important thing is to preserve the positions we talked about. So for example, if I have the query MAN sagt. MAN, again, this is the company, so here it's important to look at the case. But concerning the sagt, which means say, it's important to have the lemmatizer or stemmer in order to match this query to this text in a document. So I need, in one phrase query, I need a combination of two different normal forms, one which is case sensitive and the other one which is from the stemmer or lemmatizer. More interesting here, my phrase query is book of Kauter Tapai. Yeah? If I don't know her personally, I probably don't know how to correctly spell her name. So in this phrase query, I need, in order this phrase query to match this text, I need the lemmatizer normalization here and the phonetic normalization for the name in one query, in one phrase query again. Yeah? Here another example with the phonetic search. People might want to search phonetically for the name Muslim. And then they get a lot of hits for the word Muslim because we saw it has the same phonetic normal form. Then they might want to express I'm looking phonetically for Muslim, but it should not be the word Muslim. Yeah? And if you try to say this with an and not, you see it's not what you want, because with an and not, which refers to the whole document, you wouldn't get the document Mr. Muslim is a member of the Muslim Society of Munich, because the and not would forbid the whole document with this Muslim. So what you need here is you need to compare positions. You need to say to be able to have a query which looks for phonetic normal forms of Muslim, but on this position you don't want to have the word Muslim, which is another form, which is not a phonetic form. So you can express this with a SpanQuery. You can say okay, what we say here is we want the phonetic match for the this is the phonetic normal form of Muslim, but not the exact term Muslim. Again, I have different normal forms, different types of terms, and I have to compare their positions. Another example where it becomes interesting for the search to have different types of terms in one field is if I want to search for a person who founded Microsoft. Founding of Microsoft, that's a normal search, but the person, it's a named entity, a different type of term, and it should be very close in the document to founding and to Microsoft. This is how it works. We call it semantic search. Such query like who founded Microsoft? Wer hat Microsoft gegründet? It can be translated to something, give me an arbitrary person, which has been identified by the named entity recognition, very close to Microsoft and gründen and maybe synonyms of it. And what you get as hit is this document and highlight it because you had looked for person names, the persons here. And this is what Google produces, at least what Google produced before the knowledge graph, because now Google is able to answer this question with the knowledge graph. But, for example, not this one. Where are factories of Audi? Wo liegen Werke von Audi? Again, wo, looking for a location, we get this hit because here in this document we have very close a lot of locations, Werke and Audi. So again, an example where you need different normal forms and the position information comparable. So this is why we came up with the idea of the typed index. So the situation is we need different types of terms in one field. These types are term properties. So the first idea to use payloads or so, payloads are for occurrences of terms. For really, they are in the positions list. So these types are properties of terms. So we need another place where to put it into Lucene. And unfortunately, there's no such place currently. What we can do is we can use prefixes, and that's what we do. So we have this is what we currently use. We have this v underscore for full forms. This is for diacritic normalizations, this n. This is for phonetic normal forms. This is for named entities. For example, we can have a named entity, a general entity for each person that was identified. That's a term with a long posting list, because each person that has been identified in the index is in this posting list. This is a person name which contains Braun. So you can really look for Braun as part of a person name with this kind of term. And what we additionally do is these are the base forms we get from the lemmatizer. So we have this B, the category, and so this means it's a base form, category is noun, and the word is book. So this is how we represent types of terms currently. And this offers quite interesting possibilities for multilingual search, because we can also encode the language as a property of the term with such a prefix. So the standard approach for multilingual search, and it's still the approach we also follow currently. The standard approach is generate a language-specific copy of every content field, at least in the Solr in the schema, and so configure language-specific analyzers for each of these fields. So you have one analyzer for German content, one analyzer for English content. Yeah? And in the indexing chain, you have a language identifier, or you might have another possibility to, the language might come with the document already, and depending on the language, you copy the content into the language-specific field, and the configuration takes care so that the correct analyzer is used for this language. So the language-specific analyzer is used. And during search, either you know via the GUI configuration, you know the language the user is using. In most of the cases, you don't, so you have to expand to all languages. So you can use multi-field QueryParser to expand the query to all language-specific fields. But this is not a solution for mixed language documents, because you have to identify, at least for each field, you have to decide this is English, this is German, and then copy the content to the language-specific copy of this field. The alternative approaches, what you can do with the typed index, you could choose an analyzer, again, depending on the language, but not use different fields. Instead, the analyzer should generate terms with prefixes which contain the language information here. Yeah? And then this is what happens during indexing. And during search, you need something like a multi-analyzer query parser, which, if you don't know the language of the user is using, which expands to, with all language-specific normalizations, to these terms. But the interesting thing is, you can have in one field, for example, if you have a French or German document which cites a long passage of English or some sentences of English text, you could simply switch within this document and have in the same field German normal forms for the German part and English normal forms for the English part. So with this approach, you can correctly treat mixed language documents. And this is a summary of the advantages of the typed index to the standard multi-field approach. So with the typed index, it's easier to keep positions aligned for different normalizations than in the multi-field approach. Usually, if you have different normal forms like phonetics plus some stemmer, usually you use the same tokenizer. In the multi-field approach, this means you have to tokenize all these copies of your field with the same tokenizer, and the tokenizer is usually the slowest component of the whole analysis process. So from a performance perspective, it's better to have one tokenizer and then apply the different normalizations which fill all the normal forms into one field, instead of having different fields and applying the same tokenization again and again. Next advantage is you can reuse existing queries like phrase queries and multi-phrase queries, and SpanQueries, of course. Because if you had these different normal forms in different fields, a phrase query doesn't allow terms from different fields to be added in one phrase query, or to use terms from different fields to compare positions. And you have the possibility to treat mixed language documents in a better way, even the possibility to use, besides your statistical approach, which can determine for certain byte sequences, it can guess the language. You can use your lemmatizer results as an additional input for the decision when in your document the German section ends and the English section starts, because usually at this boundary the German lemmatizer stops to find normal forms, but the English lemmatizer starts to find such normal forms. So that's it. Any questions? You're asking why we're using prefixes and not suffixes here.
Like if I wanted to know all the Browns, whether it be a last name or a color, then suffix would be useful for that.
Yeah. I think, of course, we in the term dictionary uses the prefix encoding and also the finite state. So I think common prefixes are more. The more common prefixes you have, the bigger is the efficiency of the finite state machine. And I think we are using only a limited number of prefixes, and so I think it's better to have them in the beginning, and you can save a little bit more space than in having it as suffixes. Yeah.
So similar problem of putting all that prefix metadata inside tokens.
Unfortunately not, because payloads are intended to store additional information about a specific occurrence of a term in the document. You can use them, for example, to store layout information also. Yeah, but it's you store their information for a specific occurrence of a term, not for the term itself. So, these types or categories are properties of terms, not of their specific occurrences. So payloads are not the right place here.
You talked about normalization, and well, your examples were with a proper text of the news media, but we also have, like, on the social media, when people using, smileys instead of punctuation and whatever else. Have you faced any problems with that, like how to do normalization in that sort of text?
Yes, of course. Actually, most of our customers are in the enterprise search field and publishing companies. So we don't work with social media text or Twitter texts very frequently. But what helps in this case, maybe you can use Thesauri. Yeah. So you can, yeah, I think that's, what helps also a lot is something like the word delimiter stuff from the Lucene contributions, which has been developed for the e-commerce stuff. So splitting at number and letter changes or a camel case and Thesauri, I think.
Solution. Then you maybe want to boost like hits for a lemmatized version of the word higher than for a phonetic hit.
Yes, of course. Boosting is very important in this. If you have different normal forms, it's not a matter of having a hit, not having a hit or not having it. It's a matter of boosting. So, for example, if the user, what we do, if the user types in the query, uses uppercase letters, that's a hint for us that the user has really some intention, because normally users don't do it. So we boost these matches for these normal forms much higher than matches for the lemmatizer or stemmer. And again, we boost the lemmatizer or stemmer matches much higher than the phonetic matches. Yes, and it's configurable. Yeah, and we also have different search modi where you can switch off phonetic search, or so. Even extensions of the QueryParser where you can put, like we use a small equals E equals F for the search mode of different parts of the query. Yeah. So just if you are interested, we really offer these analyzers, these lemmatizers for, I think, about 12 European languages, most important 12 European languages. We offer these analyzers as plugins for Lucene, Solr, Elastic. So if you're interested, just send me an email. And I come back to you.
Do you support any East Asian languages,
Um,
like Japanese?
We don't have to, because there's a very good solution in the Lucene contributions for Japanese, and we also have a solution for Chinese, for segmentation. So, and all this in the same way as other normal forms you might use for a specific application, all this can be integrated. So in this multilingual approach, of course, you can integrate Japanese and Chinese, but not the same tokenizer, so it's a little bit different there. But also you could use it in this mixed language document approach, and I think it's not limited to the normal forms I presented you. You can use all other normal forms within this typed index concept. Yeah.
So you said you use limitizer for this. Do you use some part of speech tagging or any other technique to disambiguate the output of the limitizer?
Not currently. We are working on that. It's not so important for search. There are not so many cases where it's maybe, yes. But we're doing a little bit heuristic already for this disambiguation. If we see that a user query is ambiguous concerning has more than one base form, then we prefer, again with a boost, the base form that is if one of the base forms is identical to the user query, we prefer this one, and this helps a lot. Yeah. But of course, for the named entity recognition, something like part of speech tagging is important. Everyone wants to go to lunch, I think. Thank you.